Right. So we started the number system lesson, and what we have done is we discuss about what are the different types of number systems, and then we discuss how these number systems are being like used uh, uh, in the computer, right? So, and we discuss about what are the number systems that we are going to refer with. So there we uh, get to know, like, there are four types of number system, like binary, octal, decimal, and hexadecimal. Thereafter, we went through the terms which is called most significant digit and least significant digit. So according to that, for binary number system, we get to know there are something called most significant bit and least significant bit, right? Then we start the conversion between number systems, right? So I told you there are four categories, and according to that, we start doing the decimal to non-decimal conversions, right? Now, sometimes in your school, uh, those teachers may do this as three separate conversions, right? So I'm doing it in a one particular conversion, right? So what we have done is, let me recap it to you. So we convert the decimal number into a binary number over here. So decimal into non-decimal in under the decimal into non-decimal conversion. So what we have done is, since we are converting it to the binary, we take the decimal value, which is 27, and divide it by divided from the base that we are going to convert into, right? So because of that, we divide it by 2. So how far we are going to divide it by 2? Until we find something less than 2, right? So whatever the number we are going to divide, right, the base that we are going to convert, we are going to do the division until the answer is something less than the dividing number, right? So once we have something less than 2, we stop dividing the things, and we take that particular answer with the remainders that we have written in each and every division from top to bottom to generate our number system, or like to generate the equivalent number for the decimal number which is given, right? Okay, so do you is there anyone who's still not getting this conversion? I mean, no, so I can help you to like make things clearer, much clearer. Okay, great. Right, now today, now since I have done the conversion with the decimal into binary, I'm going to show you, let's say this is example number 1. I think you have written this. Please modify it as example number 1. So put a 1. So I'm going to do the example number 2 to show you how the very same decimal value converted into the octal value, right? So this time we are taking 27 in decimal. The requirement is we need the answer in octal, right? So to do that, what we are going to do is the very same thing that we have done previously. We are taking 27, and this time, what is the number that we are going to divide? Yes, people? Any suggestions? Now I'm going to convert this into the octal. So what is the number that we are, yes, Dinelka, very good. We are going to divide it by 8 because we are converting it to the octal number system. So we are going to divide it by 8. So you know there are how many? 3 8s are there. So 24 happens when 8 into 3. And how many is remaining? 3 is remaining. Right? Okay. Quick question. Am I going to divide further? Now in the previous division, we divide until something less than 2. And in this division, we are going to divide until something less than 8. So 3 is something less than 8. So am I going to divide this anymore? I'm not to, right? So then I have stopped from here. So from the point I stop, I write the answer with the remainders, right? So my final answer is going to be 33 in octal. Terunada Meka, did you got this, everyone? Yes, others? Please confirm. Did you get this or not? Osanda, we are on the previous topic that we have done last time. So we did the conversion from decimal to binary last week. So here I have illustrated how we are going to convert a decimal into octal, right? So since we are converting the decimal value into octal, we were dividing the decimal value from 8, since we are converting it to 8, until we find something less than 8 as the answer. So we found 3. So we have stopped. Okay, Udamya. I'll explain it again. I think it's better I take something little bit bigger than this number. So you will see some divisions more. Let's say I'm going to convert 100 in decimal into octal. Right. Now hear me out again. Since we are converting a decimal into octal, we take the decimal value that is given to us. Since we are converting it to octal, we are going to divide it by 8. That is the reason for dividing by 8. So in that case, you can see when you divide 100 by 8, there will be 1 for 10. First, we consider first 2 digits. So for 10, there is 1, 8, 2 is remaining. So that 2 and this 0 creates 20. So there will be 2 8s for 20 and 4 is remaining, right? So 12 is not less than 8. So therefore, we have to divide this again. So once we divide it, we can have 1, 8 for 12, and 4 is remaining, right? So now, the answer that we have gained is less than, right? People, I'm very sorry, some internet problem occurs. Let me share the screen again. Yeah, so what we were talking about is we are given the value 100 to be converted into the octal. So we take the 100 and divide it by 8. So we had 12 8s. 12 into 8 is 96 and 4 is remaining. Since 12 is not less than 8, what we have done is we divide the 12 again by 8. Then we had 1, 8 inside the 12 and 4 is remaining, right? So now 1 is something less than 8. So what we are going to do is start from the place we stopped writing the answer and write that with the values of the remainders from bottom to top. That means 100, once it is converted into the octal value, it's going to give you 144 in octal. Is that clear, everyone? Please confirm. Right, great. Okay. So likewise, let's see what happens when the what we take. Let's take 200. 200 divided by 16. Right? So I am going to, as a third example, I'm going to convert 200 in decimal into a hexadecimal. Now hexadecimal, we know the base is 16. So you know the drill. Since a decimal number is converted to a hexadecimal, we take the decimal number and we are going to divide it with what? Yes, people? Any suggestions? We are going to divide this with 16. Very good, Dinaka. Right? So 16. Right? So for 20, there are 116. 4 is remaining. That 4 and this 0 will create a 40. So for 40, there are two 16s. 16 into 2 is 32. And 8 is remaining. Right? Okay. Are we going to divide this further? No, we are not. Why we are not dividing this further? What is the reason? Yes, why we are not dividing this further? What is the reason? Because we found what? A value? Yes, very good, very good. Right? Because we found a value less than 16. Now, be very careful when you are writing the answer now. You know how to write the answer. The method is start from the place where you have stopped and then goes with the remainders. But when you are writing, like when you are considering something larger than 9 in hexadecimal, how did we represent those? 10 as capital A, B as capital, 11 as capital B, 12 as capital C, right? So we don't write 10. Instead of that, we write capital A, right? So A is for 10, B is for 11, C is for 12. So we got 12. 12 means what? This is C, right? So we are going to start from here and write it upwards. So remember, any of the symbols, the division එක කරගෙන යනකොට ඔයගලන්ට උත්තරේ විදිහට එන එක හරි ඉතුරු වෙන එක හරි 10ට වඩා වැඩි අගයක් වුණොත් you have to represent it with the corresponding capital letter, right? So here 12 is C, 8 can be represented as it is. So your final answer is going to be C8 in hexadecimal. Got this, people? Right. Okay. So let's write this down. Ravindu, it's like this, Ravindu. If it is 10, we are going to put A. If it is 11, we are going to put B. For 12, it is C. For 13, it is D. For 14, it is E. And for 15, it is F. Those are the capital letters that we are using, Ravidu. Right? So we are not representing 10, 11, 12, 13, 14, and 15 in hexadecimal. Instead of that, we put A, B, C, D, E, F as accordingly. Clear, Ravidu? Right. So shall we write this down, people? I think we have written the decimal to binary conversion. Right? Am I right? You people are done with the first example, right? Yes, anyone? Lamai, you can hear me clearly, right? People, can you hear me clearly? Please give me a confirmation. All right, okay. Right, Dinelka, did we write the example number 1 to we did, right? Yes, right, okay. Okay. So let's go with the second example. Okay, here we go with the second example. Check the second, then I'll show you the third. Tehara, example 3 and example 4. That's what you need to write down. I'm sorry, example 2 and example 3, not 3 and 4. Right, I'm moving a little bit up. Right. And if you are done with writing, I'm going to give you some calculations, right? All you have to do is just convert it and send me the answers through the chat, right? Right, so I'll write the question right over here. Convert the followings into decimal. I'm sorry, not into decimal, into binary, octal, and hexadecimal. Hexadecimal equivalence. Right, so I'm giving you two decimal values. All you have to do is you have to convert each and every decimal value into all other three number systems, right? 419. So I need the binary representation, octal representation, and as well as hexadecimal representation, right? කලබල නැතුව හිමීට කරන්න. And it's better you do the workings, people, right? Don't use any calculators and all these things. You won't be having anything in the examination, right? Send me the answers. Dulaputala, mind your mics, Dulaputala, right? All right. Ravindu, if you got 19, Puta, definitely you have to divide it again by 16 because we stopped the dividing when we receive something less than the dividee. Right? අපි divide කරන number එකට divide කරන්න ගන්න number එකට වඩා අඩු අගයක් ආවොත් කියන්නේ binary නම් දෙකට වඩා අඩු අගයක් ආවම අපි නතර කරන්නේ. If it is octal, we stop when we have something less than 8. If it is hexadecimal, we stop when we receive something less than 16. Then your division is wrong, Ravidu, because when we divide by 16, we won't be able to have something more than 16, right? When we do the division, it always give us, the remainder part will always be something less than 16. It is not going to be something more than 16. And if anyone find hard doing the maths, just let me know, then I will go through again. තෙසඳු තෙසඳු අපි මෙතන මේ සමීකරණ දෙක ලියාගත්තා. Right, last week we finished from the place from here Nipata. So we wrote the example 2 and example 3, then I gave some question. So I made a copy karagena questions tika liyanna ganna, so it will be okay. Right, Dinelka, go through the very first binary conversion. It's the only mistake that you have made, right? The first one, 419 binary conversion. Go through it again. Others are okay. And Udamya, your answers are correct regarding the first one. Osanda Puta, send me the answers. I need to know. I need to see what are the answers. I just type it. Yes, Ravidu, we can take 2D as the answer. It is going to be the answer of 45. Everyone have to send me the answer, right, Ravindu? Okay, Ravindu, that got a problem. 419, you have to work it again, I think. There is some mistakes. කොහරි එක තැනක් වරද්දගෙන තියෙන එක නිසා යෝක වැරදිලා තියෙන්නේ. Just go through. Udamya, yes. Yes, yes, okay. First one is 45 is correct. Yes, well done, Dua. Januki, yes. Right, okay. Yes, yes, that is correct, Januki. Well done. Sulakdi, yes, okay. Right, okay. Yes, well done. All are correct. Well done. Dinelka, yes, that is the answer, Dua. Yeah, that is where you have went wrong, Dua. Right, now it's okay. Pehara, yes, all right. Very well done. Correct, Dua. All are correct. Well done. Sayuri, Yes, first one. Yes, that's correct. That's correct though. That's correct. Keep it up. Keep it up. Yes, second one is correct as well. Third one is correct as well. Osanda, I think there is a slight mistake. Osanda, uh, Osanda, this is regarding 419. Sairi, yes, those are correct, Dua. Well done. Osanda, there is a slight mistake. Ravindu, Ravindu, still there are some problems, Ravindu. කොත්තනක හරි එක තැනක් සෙටල් වෙලා නැහැ. හරි. මම දැන් පළවෙනි එක කරනවා. බලන්නකො එහෙනම්. Right? Let me do the first one. Just see අනික් කට්ටිය බලන්න උත්තරේ හරියට ආවද කියලා. කරපු අයගේ වැරදි තියෙනවා නම් බලන්න කොතනද වර්ධින්නේ කියලා. Right? So I'll take 419 and I divide it by 2. So there will be 2 for 4 and nothing for 1. For 19, there will be 9. 1 is remaining. Then again, when I am dividing by 2, yes. Yeah, Ravi, that's correct. That's correct. Yes, yes. Well done. Right? No, not the C, Ravindu, not the C. Just see, go through it again. I'm doing it now, see. Right? 209 divided by 2. So it's going to be 104. And 1 is remaining. Divided by 2, 52. 0 is remaining. Divided by 2, 26. 0 is remaining. Divided by 2, 13. 0 is remaining. Divided by 2, 6. 1 is remaining. Again, we have to divide by 2. 3. 0 is remaining. Again, divided by 2. 1 and 1 is remaining. So now I receive something less than 2. Yeah, that is correct, Ravindu. That is correct. Right? So what we are going to do is start it from the place you have stopped and go to the up. So that gives you 1 1 0 1 0 0 0 1 1 in binary. Yes, Ravindu, that is correct. Yes. Well done. Right? So here comes the binary conversion of 419. Right? It's quite big. So you have to do it very carefully. They can bedan anything. Right? So I'm going to do 419 to take the octal equivalent. So 5 for 19, there will be 2, 3 is remaining. This is 6 and 4 is remaining. So I can write from top to bottom 643 in octal. Januki, yes, that is correct. Well done. Right? And when I'm doing 419 in 16, so there are 2 for 41, 9 is remaining. For 99, it's going to be 6, 96, so 3 is remaining. In 26, we divide by 16, so 1 and 10 is remaining, and 10 means A. So now I receive my answer something less than 16. So I'm starting from there and writing to the top. So it gives me 1 A3 16, right? So this is the way your first answer is going to happen, right? Good. Almost everyone send me the correct answers, even though some are got mistakes at the very first place. They make the the corrections. That is what you need to do, people, right? ඔගොල්ලන්ට වර්ධින එක සාමාන්‍ය දෙයක්. වැරද්ද හදාගන්න. ඒක තමයි වෙන්න ඕනේ. Right? Okay, I'm not going to do the 45 because since it is a simple calculation, right? Okay, now I'm moving to the second type of our calculation, right? So the second type is converting non-decimals into decimal number system, right? Okay, so you may have the heading converting non-decimals into decimals. Right. හරි. දැන් වැඩ මොනා හරි කරනවා නම් ගණන් තාම හදා ඉන්නවා නම් just stop it for a moment and hear me out. Right? Now here what we are going to do is we are going to convert the non-decimal values, that means octal values, binary values, hexadecimal values into its decimal equivalent. Right? So binary, octal, hexadecimal will be converted into the decimals. Again, this is going to have a very same technique, right? So what is the technique? Now, as an example, let me take the first example. So I want you to convert 101111. Let's have another one, right? 111 complex on it. 10110. The binary value into its decimal equivalent. This is what we want, right? So what are we going to do is, first we are going to take the binary value and write it down again. It's better you write it with a little space in between the characters, because we need to consider something called place value over here. Now, do you remember the thing I told you about the abacus? Right? When you say this is like ones, tens, and hundreds in an abacus, I told you these things can represent in 10 to the powers. 10 to the power 0, 10 to the power 1, 10 to the power 2. Right? So if you feel something like this, right? So you say there are 3 ones and 1 tens and 2 hundreds. That is how you are going to represent 213, right? So 213 will be created with 2 hundreds, 100 into 2, and 110, that will give you 210, and 3 ones, that will give you 213. So since this is a decimal number, it has 10 to the powers 10 to the powers as its place values. These are called place values, right? Why it is having 10 to the power place values? Because it is a decimal value. So same applies to the binary numbers. If the decimal values are having 10 to the powers as the place values, what are the place value that the binaries are going to have? Which to the powers? Any suggestions? Well done, Tesandu. 2 to the powers. Very good. Right? Very good, Osanda. Right? So all we have to do is just write the place value, corresponding place value, right beneath the symbol. So this is going to be 2 to the power 0. This is going to be 2 to the power 1. This is 2 to the power 2. This is 2 to the power 3. And this is 2 to the power 4. People, are you getting this? So far, is it okay? Give me a confirmation. So we are given a binary value to convert into decimals. So we consider place values. Since it is a binary value, it has 2 to the powers. Right? And tell me this. If you consider an octal value, what kind of powers it has as the place values? If it is an octal value, 8 to the powers. Very good. If it is an hexadecimal, it's going to have 16 to the powers. Very good, Udamya. Right? Okay. Now, game is not over yet. Right? Now, what we have done is we write the binary value. We took the place values. And then we are going to take the values of these powers. So what would be the values? Now in 10 to the powers, 10 to the power 0 means 1. 10 to the power 1 is 10. 10 to the power 2 is 100. 10 to the power 3 is 1000. 10 to the power 4 is 10,000s, like that. So how it's going to be these values? 2 to the power 0, what's the value? Yes, 1, very good. Any 0 to the power going to represent 1, right? Not the 0, right? 2 to the power 0 means 1. Even 3 to the power 0 means 1. 10,000 to the power 0 means 1 again, right? 0 power එක ඔයගලන් නිතරම දෙන්නේ 1 කියන value එක. 2 to the power 1 represents 2. 2 to the power 2 represents 4. 2 to the power 3, what it represents? Yeah, 2 to the power 3, 8, very good. 2 to the power 4, 16, well done, right? So we consider the binary value, we wrote the place values into the powers, then we convert it into the values. Now what you are going to do is, you consider the place value and you consider the symbol value, the corresponding symbol value, and you are going to multiply this. Multiply. Right? So what happens? 16 will be multiplied by 1. 8 will be multiplied by 0. 4 will be multiplied by 1. 2 will be multiplied by 1. 1 will be multiplied by 0. Then after, you have to add these values. Simple, right? 16 into 1 is 16, plus 8 into 0 is 0, 4 into 1 is 4, 2 into 1 is 2, 1 into 0 is 0. So what's going to be the answer? 16 plus 4 is 20, 20 plus 2 is 22. Here you are getting your decimal value. Yes. Is this clear, people? Right, great. Okay, write down. Right, well done. Yeah, then I'm going to do the other two conversions. Then we can do some other maths as well. Right? Okay, write this down. දැන් ඔයගලන්ට ටික දවසක් යනකොට මේ පවර්ස් ලියන්න නැතුව කෙලින්ම පවර් එකට දාලා වැලියු එක ලියන්න පුළුවන්කම එනවා. When you are practicing, right? So on those days, you can straight away go to the values of the power. Okay, one is done. How about others? Right, two are done. How about others? Okay, so let's go to the second example. Now here I'm going to convert an octal value to the decimal. So I'm taking 247 octal. Going to convert into the decimal. Yes, now you know the drill. Since this is an octal number, we have to write the powers of octal numbers as the place value, right? So we take 247. Then we represent the powers. So what would be the powers? A to the power 0, A to the power 1, and A to the power 2, right? So A to the power 0 means what? It is 1. Very good. And A to the power 1 is 8. A to the power 2 means, what is the value of A to the power 2, people? 64. Very good. Right. So then what we have to do is, again, in the very same way, we take the place value, we take the corresponding character value, and we multiply. Right, so that means 64 into 2 8 into 4, 1 into 7. So then we are going to add the answers. So that gives you 128 plus 32 plus 7, which is going to give you 167. Am I right? 28, 30, 60, 67. Yes. That is going to be your decimal value. Okay. Quickly copy this down. Then after we'll go for a hexadecimal one. Right. Two are finished. How about the others? Right. Okay, here we are going to do the third example. Right, so my third example is, I want you to convert A5F hexadecimal value into the decimal value. So we know the drill. A5F hexadecimal values. So it has 16 to the power 0, 16 to the power 1, 16 to the power 2. So 16 to the power 0 is 1, 16 to the power 1 is 16, 16 to the power 2. What it is going to be, people? 256. Very good, Damya, very good. 256. So now we know what to do. Take the place value, consider the symbol value, and multiply. So that's going to give you 256 into 10. 10 into A means 10, right? And 16 into 5, 1 into 15, because A means 10, F means 15, right? Then we are going to add these things up. That's going to give you 2560 plus 80 plus 15. So that gives you 2655. Am I correct? 2655. Let me see again. Yes, so 640, 55. Yes, yes, that is correct. So it is 2655. That is how you do the conversion of hexadecimals into a decimal. Okay, write this down, then I'm going to give you some math to do. Right. So the hexadecimal happens like that. So for the people who have finished, here comes the questions. The question is, convert the followings into decimal equivalent. Right. So Roman number 1, 1, 0, 0, 1, 0, 1, 1. It is in binary. And the second one, let's say 564 in octal. Third one, what I'm going to give you, 5BD in hexadecimal. Let's make this 5 2D. Right. Try it as quickly as possible. Yes, Tesando, that's correct. Yes, Osanda, that is correct as well. Yes, Tesandu. Yes, that is correct. Second one is correct. Well done. Ravidu, that's correct. Osanda, that's correct as well. Yes, Ravidu, that's correct as well. Hold on, hold on. Second one, there is a problem. That's not the answer for the second one, Ravidu. Third one, not again, not again. Just go through again. Ravindu, second one should have 8 to the powers. Third one should have 16 to the powers. Pehara, yes, yes, Dua. That's correct. That's correct. All are correct. Well done. Ravindu, yes. Oh, there is a slight mistake, I think. Ravindu, පොඩ්ඩක් වෙනස් වෙලා තියෙනවා. It's going to be something 300, but චුට්ටක් ආයි බලන්න. Give it a try. Give it a try. That's correct. Yes, Ravidu, that is correct. That's the answer. Well done. Yeah, Sulakdi, the answers are correct. Well done. Januki, yes, answers are correct. Well done. Dinelka, yes, all answers are correct. Well done. Ravindu, third one has a problem. Tesantu, third one is correct. Osanda, third one is correct. Ravindu, go through the third one again. It's 16 to the power 0, 16 to the power 1, and 62 to the power 2, which means 1, 16, and 256. Sayuri, yes, that is correct, Dua. Well done. Senya, yes, the second one is correct. Second one is correct. Go for the third. Right. So almost everyone is given me the answers. That's good. Keep it up. Keep it up like that. Yeah. And I'm searching for the people who have not replied me. Yeah, Metul. Puta, how about your answers? Ravindu. Oh, Ravindu, තව පොඩ්ඩක් බලන්න පුතේ කොතන හරි වැරදිලා තියෙනවා. Third answer එක. Metul, how about your answers, Puta? Udamya, yes. Yes, that's correct. Well done. Well done. And Ruven Chandrasekhar, I didn't receive your answers too, Buddha. Ruven or Rovin. Others, I receive yours. Right. Yeah. So let me do the third one since some are struggling to have the answer of the third. So third one is 5 to D 16. So if I think about the place values, Udami answers are correct. I told you, neither. Sorry, I thought it was just came. Right, so this is 16 to the power 0, 16 to the power 1, and 16 to the power 2. Right, which gives you 1, 16, and 256. So then what we are going to do, Senya, yes, your answer is correct. Well done. Ravindu. Ravindu balana කොතනද වැරදුනේ කියලා. Right? 256 into 5. Right? So that is what we are going to do. So 256 into 5 plus 16 into 2 plus 1 into D means A, B, C, D. 10, 11, 12, 13. So 13. Right? So let's do the 256 into 5. It is going to give you 5 into 6 is 30, 3 is remaining, 5 into 5 is 25, 25 plus 3 is 28, 2 is remaining, 5 into 2 is 10, 10 plus 2 is 12. It's going to give you 1280. 16 into 2 is 32, plus 1 into 13 is 13, right? So this is going to give you 1325, right? Okay, so people, just see whether your workings are okay. Yes, Ravindu, never mind, never mind. Just learn from it, that's all, right? All right, so we are done with two types of conversions, right? And we are going to go for another two. So once we're done with the conversions, there is only a few to wind up the session, wind up the third lesson as well, right? Then we can go for the fourth lesson, which is about the logic gates, right? So yeah, so I'm going to end the session from this point, people, because if I start the next one, we don't have much time, just 1 minute more. So I'll see you on next Saturday, right? And we'll try our best to end the conversions, right? If we got the chance, we'll end the lesson as well, right? So have a very nice weekend, people. Be safe, stay safe, right? And I'll see you on next Saturday for the same time. Thank you very much, people. Right, okay.
Thank you, sir.
Yeah, thank you. All right, thank you.